Okay, so I'm recording again. Here we go, you guys. So, you guys say it does match up when you slide it up to triangle 2?
Yes.
So it does match up when we go to here. So will you write translation?
Where?
So we call that a translation. Not a transformation, a translation. Which really means just slide it. And how much did we slide it?
Up 2 squares.
Up 3. Up 3. Up 3. Okay, so we know they're equal. We know they're congruent. Okay, how about triangle 3? Where is it? Oh. Okay, so now it's a little tricky. What transformation are you going to use to get to here? Wait, if you flip it, will it land on there?
Yes.
No.
I don't think flip's going to work. Try it. Try flipping your patty paper over. Mirror is a flip.
And then you gotta rotate. Isn't it a rotation? Reflect.
It is a rotation.
Rotate it 90 degrees.
I don't want to say how many degrees, but try rotate.
90 degrees.
No, it doesn't. Yeah, it does.
Yes, it does.
Yes, it does. Yes, it does.
Yes, it does.
Yes, it does.
Okay, I'm recording and that sounded awesome. Yes, it does. Okay, so
Yes, it does. Because flip it black or black.
hey, you might on the top of your paper write top, so you know that when you. Well, I guess you don't need to do that. Never mind. So, is it a rotation of 90 degrees?
Yes.
Rotate 90. How much? So.
I said 90.
Oh, clockwise, right? Wait.
Counter.
Counter.
It could be clockwise too. It's got to be nice.
You could go 270 clockwise
He's got a good.
or 90 counterclockwise.
Just kidding.
Would that work?
Hey,
Okay.
are we supposed to do that like sketch thing that we never did?
We're working on it. Yeah. Sorry.
But why are we doing BDI?
Okay. We're doing triangle def every time. So we're always referring back to this one. How about triangle 4? What do you think? Are they congruent?
Counterclockwise. Isn't it bigger?
Here it is. Now I'm going to do... Are we flipping it? What's the mathematical word for flip?
Mirror. Rotate.
Reflection.
Reflect. We're reflecting it across what though?
The y-axis.
Yes, the axis, which some of you do too much. Just kidding.
We access too much.
Are you still recording?
Yep. That was a good joke, huh? Put on there. The axis.
So you really have to record us and turn that in?
I do.
Someone's calling you.
Write down that number.
801-703-5.
Okay, here we go, please. Shakaila has a question about this being congruent.
No, they're not.
Shakaila says they're not equal. Draw a line through there. They're not equal. Why are they not equal? How much bigger? Isn't that 3 units right here? Okay.
Are we turning this paper in?
Yep.
What do we
No.
trace?
And this is 2, right? So not
Not.
congruent. Not.
Oh, Mac, did you hear that, Mr. Mac?
I'm moving on. Here we go.
No. These guys, your wife's number.
Oh, gee, Caden.
Number.
Ugh. Tear your face off. You even talk to her.
I don't even have.
Shoot, that was on here. Oh well. Okay. Number 5. Is 5 congruent?
No, 5 is not.
Obviously not. It's huge, right? Congruent means they're equal or the exact same size and shape. So 2 and 5, you guys, are not congruent, but are they similar?
Yeah.
Wait, how do you know they're similar?
All you have to do is times
Raise your hands. Shh. Harrison, why are they similar? Okay, so will you guys prove to me that they're similar?
I got you.
Harrison said they're the same shape. This one's just enlarged. But how can you prove that to me? It looks like it is, but how do we know for sure?
Well, I was the first one to find out.
Okay, Casey. Oh,
That's right.
Harrison, go ahead.
Just like get the, you divide, I don't know how to, you like get the,
Scale factor.
yeah, scale factor.
How long is this, guys?
6.
Okay, let me teach. Okay, so from 2 to 6, how many times bigger?
3 times. It's 3
Three.
times bigger.
This is why we enlarge stuff. So it's 3 times bigger, right? But how do I know this is 3 times bigger? And I don't even know the length of this.
Count it.
Can you
Because it's.
can you count the stairs? How many stairs? 2 1-by-1ers, right? Shouldn't this have the same? So 2 1-by-1ers. 2 more 1-by-1ers.
That's 2.
Yeah.
2 more 1-by-1ers.
That's 3.
3 times bigger.
Yeah.
See, I told you. It's gotta believe in me.
So we say that this squiggle, they're similar. That squiggle means they're similar. Okay? This squiggle. See, it's just a squiggle. So, will you put that in your pocket?
Yep.
So, there's another way to check. Does anybody know the other way to check to see if they're similar, Zach?
The y, check the slopes of the 2 angles.
The slopes are the same, aren't they? Do you guys see that? 1 over 1, 1 over 1.
Oh, yeah. Oh, yeah.
There's another way to check it. Thank you for that. Okay? Take the one you drew. Take the little guy that you drew. And if you match up the angles, just match up this little angle with this little angle and see if they're the same.
Yeah, the acute angle right there.
Acute angle, acute angle.
Yeah.
But are they exactly on top of each other?
Yeah.
Yeah.
Move it to here now. Move it to the big angle.
Oh my god.
Okay?
Yeah.
We now think, if you got 2 angles that are the same, do you even need to measure the third?
Nah, bro. Nah.
Yes. If the answer's told, if the question's told.
If I know, guys, you guys are being really good now. If this angle and this angle are the same, and I know that this angle and this angle are the same,
Oh, and the top angle is the same too, right there, the top.
doesn't this one and this one have to equal 180? The 3 of them equal 180 anyway?
Yeah.
So that has to. You only need 2. Okay? It's called angle, similarity, but you don't need that till like high school.
Can we break that word?
You won't need that for a long time.
You mean, right? We won't need that.
No. Okay. What did we say? Same enlarged by 3, right? Is that our proof? Or, Carol, we could say the angles were equal, right? Or we could say, Chancey, we could say the slopes are the same, right? Okay, I'm still recording. Thank you very much.
You're welcome.
Keep me looking. So 6 and D, yeah.
Well, how come I have 1 extra line?
I just recopied it and started over. Sorry.
No, I'm talking about right here. I put
Yeah,
6,
we-
7, 8, 9. There's still 1 more line.
Forget about it. Okay.
Forget about it.
So what am I doing to get DEF on top of 6?
Transition.
Good, close. Translation.
Dang it, Ah. Get it together, Shafi.
It's a slide of how much?
2 units.
Yeah, 2 units.
4 to the...
Left. Wait, which one's 2? Oh.
Fast recording.
Well, they all move 4, right? Put your pencil on any dot and it moves 4 to the left.
Either left or right, depending on which of the triangles.
Oh, yes. We're always starting with DEF, though, for this. But you're right. Okay. Number 7. 7's that little tiny one. Right there. Okay? So just look at those 2. You say they're similar, so let's draw the symbol, similar. But let's prove why they're similar. Match up the angles. Good. Match up the angles. Actually, use your patty paper.
Your pad?
Patty paper. And lay the patty paper on top of the same.
And make that, no, just make that match with the patty paper thing.
So match D to here.
What?
Do those match?
Yeah.
That's your back.
Okay, what are we doing on the patty paper?
What should we write,
And then-
shrunken or decrease?
Do these match up? Okay. So you could look at the angles and see, right? Who's actually looking on their patty paper? What, Harrison, will you show Nicolina? She wasn't here. Do you know what we're doing with the patty paper? Will you show?
Mr. Mack, I'm confused on what we're doing.
Well, I gotta move. Sorry, gotta move on.
No, I'm saying, what are we supposed to do on the patty paper?
Well, I already kind of went over it.
Well, I thought we had to bring
Could you look at the sides too, you guys? How many times smaller is the little one?
Two.
Half, two times smaller, or half as big. Okay. Zach said the slopes are the same. Are the slopes the same? Of that one.
Yes, no.
Look at it. Isn't it just down one over one?
Yeah. Well, oh, yeah.
Okay. Let's write it. Angles are equal. That's good enough. Angles are equal. Sides are proportional too, right? Oh, do you know a quicker way to write angles are equal? Watch. Angles
Triple A.
are equal.
Oh,
That's even quicker, right?
Because equal doesn't start with an A.
That's an angle, right? Angles are equal.
You know what's even faster?
Looks like an L's.
That's what's up right there.
L's are equal.
That's what's up.
I said triple A, but
I'm just trying to be cool because I'm on recording. Okay. So,
I'm so smart.
number 8. It's clear down here. What do you have to do to get that to here?
No, you just have to match up 3 and 8.
What number are you?
Just match up 3 and 8? Why? Why can we just match up 3 and 8?
Exactly the same.
Oh, we already proved that 3 was the same, right?
So we just write the same thing as
So,
3.
let's just write that.
flip it.
Just match
We just
3 and 8. Because we already proved that 3 was the same as 1, right? That's smart. So how do I get 3 to 8?
Reflection. Mirror.
Mirror or reflection, right? You guys are awesome.
Wait, is it 3? What is that? 3B?
If we were doing a proof, they'd make us say, since triangle 1 is equal to triangle 3, thus, therefore, we must.
Are you going to actually have us do that?
Proofs? You're lucky you don't have to do them this year. Next year.
No, next year.
Next year, you'll be loving them.
I'm loving it.
Okay, last one, you guys. 9. Is 9 similar? We know it's not congruent, right?
There's a back.
The back goes really fast.
Better.
Promise.
It's similarity.
Will you check and see if it's similar?
Yeah, it's similar.
Tell me why you think so, Siaki.
Because the slopes are the same.
No, it's actually another.
Well, the tops are 2 and then 4, right?
Enlarged by 2.
It enlarges by 2, but is that angle the same?
No.
Okay, Zach, what'd you get?
Yes, it is.
Are these proportional? Are they similar? Down 1 over 1, down 1 over 1, right? What's this one?
Oh, everything matches up with the top one.
Look closely. Am I going down 1 over 1? I am, but am I on the line?
No. I win. You
So it's what?
No.
Not similar.
I told you it's not.
Okay? So that line right there, not similar. So it's kind of like Alex in his dream date.
Oh, good, you switched it.
Did we write that?
Not similar. Sorry. They're not proportional.
Opposites attract.
Watch.
But that's true. Opposites attract, right?
Now Alex is gonna get nice reading, girl.
Okay. Sorry, let's get rid of that. Parents are going to watch this and be like, what is he doing in class? Okay. All right. We're still recording. Thanks for being nice about it. We have to. It'll go fast, I promise. Are you working ahead of me or no?
No.
Zach is probably.
Okay, you guys are fast with coordinates.
Are we?
I think so.
What is
Remember, it's the opposite of that, right?
Barely.
It's not y over x, it's
Why?
x and then y, right? Okay. Shh. Blurt for me. You only get one blurt for these 6. What's t?
7. 4.
Where's t located?
Oh. Okay.
That's only our one.
I thought you wanted me to just say a number. Okay.
negative 5, 4?
Got it. That was t. Negative 5, 4. Kara, do I need to move you back? Okay. I know. It's good. S, blurt it.
Negative 10, 7.
Negative 10 and
7.
7.
Negative 14, 4.
Don't rush that fast.
I'm sorry.
And R is what?
Negative
Negative 14,
It's
4.
negative 14, 4.
14.
He was just seeing if we were paying attention. Right, Don? Okay. So that's the pre-image. That's the one we start with. Pre-image is the start one. Right?
Yeah.
So if you were writing a program for Mario Brothers and this was your shape, your basic shape, it's really boring. It's not Mario. But let's say you wanted Mario to duck down, right? And move forward a little when they push button C. I'll show you how to write the program right in just a sec. Seriously, it's not that hard. So what's R prime, you guys? Sorry, R prime, I didn't show you where it is. It's right here. R prime, S prime, Optimus prime, Transformers, get it? We're doing transformations.
How long did it
That
take
was
you to
a
make that?
I didn't even make it up. Some kid said it today.
I think it'll be.
He's probably thinking about it like all last period.
They probably got to.
Let's see if I can make a joke.
Probably did get it from Mr. Colby. It's always Mr. Colby. Tired of hearing about Mr. Colby. This.
Is he old?
He's awesome.
He like almost swears every other word.
Hey, we're on video. What?
What? Amazing.
What's R prime?
Makes jokes are amazing.
Negative 10, negative 2.
I said he almost swore.
Okay. How about S prime?
Negative 12, 1.
Negative 12, 1. Are you sure?
Negative 6.
Negative
Oh, no, 7. My bad.
Yeah.
Negative. Yeah.
Negative 6, 1. And T prime?
Negative 1, negative 2.
He must be.
You guys are awesome.
No, we just have
Now, can you describe in words, how would you get this to here? Just by describing in words.
translation.
It is a translation, but even more simple than that. What do you do to the pre-image to get to here?
Move it.
Slide it which way? Down, how much? Down some.
1, 2, 3, 4, 5, 6, 7.
Down 7?
Down 7 over 1, 2, 3, 4,
Wait, 7's too many.
Just kidding. 4. Wait.
6.
Down 6.
Down 6. So down 6. But how much are we going to go over?
Head up.
Yeah.
4 over. Okay? Now which one should I have written first?
Over 4.
Over 4.
Over 4. Okay. Now here's the part that's kind of cool, because this is really how they write the programming. So give me x or y. X or y can be where?
5.
Anywhere in the coordinate plane. Is that a lot of places? That could be anywhere, right?
Do we have homework this week?
So take x, y and translate it. So that what do we do to x? Look at the x values. What did we do to them to get the new one? Just look at the,
You have to make them negative.
what did we do to the x values?
You changed them.
We did. We changed them by adding what to them?
4.
You guys are awesome.
Oh, so that's all you do?
Yeah, we did that.
Look. 4 to the right, right? And then what did we do to the y values?
Subtract 6.
Okay? Guys, this is really simplistic, but it's not that far away from writing your own program, if you understand this. I'm serious. You could make your own app.
Zach's gonna make.
Okay? This is just the coordinate plane, though, right? Flat. But did you know now they have 3D printers? You knew that, sorry. So there's X, Y, and Z now. They turn the coordinate plane and lay it flat, and then they add Z. Okay? We live in that one, right?
Do we?
We live in 3D, right?
So are we printed out?
We could be printed out. We could print out an Everest.
Yeah, but it
Yeah,
wouldn't be a
you'd be
lot.
plastic. You'd be stuck. But
Let's replace that.
What is 3D printer based on? It's like profit.
Mr. Lucy says by the end of the year you can buy one for $100.
No,
You guys will be printing your kids' toys.
a 3D printer.
You won't even go to the store.
My dad's friend has one of those.
Print out money and then let's just say to power the.
You can do that with a regular printer.
I know, but it doesn't work.
Okay, last one, good people of the world. What are we doing to X? What are we doing to Y?
I moved it 5 over.
5 over. What are we doing to Y?
Yo, I'm so lost here.
3 down.
3 down. So all we're doing is shifting that over, right? 5 over, 3 down. So how should we do it? Can't we just move over 5? And go down 3? Put a dot? That's C prime. Where's D prime?
Right there.
Right where?
It's a ways a bit.
That was Thursday. Yeah, I'm done.